All right, as promised, I'm going to show you guys how to simplify this limit expression. And this is like the main kind of a thing that we're going to be doing. I'm going to give you a function. I'm going to ask you to find the slope of the tangent line at any point. I'm going to ask you to find the slope of the tangent line at a specific point. So this is the expression, sorry, just to recap, this is the expression for the slope of the tangent line at some point x. And this was the function we were given. And so we wrote this limit expression. And then we noticed that if I just plug in 0, which is how we did limits before, I end up with 0 over 0, which means I have to do some simplifying. So what we're going to do for almost exclusively on these is you're going to multiply this out and then simplify on the top, and then it's going to work out for you. So basically, x plus h squared, you can distribute. That's really x plus h. This is really x plus h times x plus h, which is x squared plus 2xh plus h squared minus 1/4 x squared all over h. This, of course, I foiled because distributing the squared in there is illegal. Now I can do it. I can probably write it right here. Probably enough room. Let's see. So this is the limit as h approaches 0. 1/4 x squared plus 1/4 times 2xh is 1/2 xh. 1/4 times h squared is 1/4 h squared minus squared minus 1/4 x squared all over h. Now, if I'm paying attention, which I for sure am, I can see that there's a 1/4 x squared here and a 1/4 x squared there. Cancel out. I get the limit of 1/2 xh plus 1/4 h squared all over h. And now what happens is what's always going to happen. I'm going to be able to, if I did all my simplifying and distributing and multiplying right, everything up here is going to have at least one h in it, and the only thing on the bottom is going to be h. So I'm going to be able to cross one h out of each one of these terms. So one h here, one h there, one h there. So the top is now 1/2 x. The top is 1/2 x plus 1/4 h. And the bottom is a 1, or like it's not there. H divided by h is 1. And now I can just plug in h equals 0. So what I'm left with is the slope of f of x for any value of x in the domain of f. So, and what that means for this particular problem is this. I'm going to put this in a box because it's pretty important. This is the slope of this graph for any x. And what I mean is, if you go up to the graph, you're like, well, what was the x coordinate here? I think it was 2. And so if x is 2, then the slope of the graph is 1/2 times 2, which is 1. And that tells me that the slope of this black line here is 1. And what this 1/2 x is telling me is that no matter what x value I have, I can always find the slope of this curve by plugging the x value in right here. So when x is 4, the slope of this curve, the slope of the tangent line to the curve should be equal to 2. And when x is 6, the tangent line slope should be 3. And when x is 10, the tangent line slope should be 5, and so on and so forth. So we're going to see some more of this in the next couple videos. So stay tuned.